Okay, graphing rational functions. So we've gone through how to find everything. Now let's actually graph these. Oh, let's start with a quote. So your mental health is more important than the test, the interview, the lunch date, the meeting, the family dinner, the soccer game, the soccer game, the recital, and the grocery run. Take care of yourself. This goes along with what I was talking about last time, but just take care of yourself. The holidays are typically a harder time, especially right now. So just take care of yourself. That's all, okay? So graphing these. We're going to go through basically all of the steps we went through last time, but now we're going to actually graph them, okay? So first, we find asymptotes and we find holes. So to find the horizontal asymptote, we look at the degrees, and the degree of the degree of P is the same as the degree of Q. So I'm just going to divide the leading coefficient. So I have the horizontal asymptote is 1 over 1, which ends up just equaling 1. So we have a horizontal asymptote at y equals 1, and I'm going to graph that on my paper. Okay, I will send you guys home with some graph paper so that you can graph these. The next thing we're going to do is we are going to find the vertical asymptote. There's no holes. So now we can find the vertical asymptote. So for this, I just looked at the bottom of this. So like the x plus 4, we're saying, well, x plus 4 equals 0, which means our vertical asymptote is at -4. Okay, so then I'm going to go over to x equals -4, and let's graph that asymptote. Cool. Next thing we do here is find the x and the y intercept. So to find the x-intercept, we're going to set the numerator equal to 0 and just solve for x. And then to find the y-intercept, we're just going to plug zeros in for the x's. Okay, so x-intercept, we have x minus 4 equals 0, which means x equals 4. So I'm going to go over to 4, and there's my x-intercept. Y-intercept, I'm going to plug 0 in, so I have 0 minus 4 over 0 plus 4, which is -4 over 4, which is -1. So we cross the y-axis at -1. Okay. Finally, we have to draw a line with the critical points on it, and let's just test points between them to see whether the function is positive or negative. Now, like looking at this and looking at my x and y intercept, I can kind of guess what this is going to look like, but this is a way to really make sure. So we're going to use the -4 and the 4, because you always use, so for your critical points, I would look at where it is crossing the x-axis, okay? So -4, we have an asymptote, and then 4, we have a point. So then let's plug in -5. Well, if we plug in -5, you end up getting 9, which is positive. So that part of the graph is going to be positive. We plug in 0, because between -4 and 4, we get a negative. So that part's going to be negative. So between -4 and 4 is negative, so it's underneath the x-axis. Then say we plug in 5, we get 1/9, which is positive, so now that's above the x-axis. So then we can graph this, and it looks like that. The graphs always just follow along your asymptotes, okay? All right, let's do domain and range. So the domain on this one, so domain, remember, is your x values. So the domain is going to be -infinity to -4, and then from 4 to infinity. Because of that asymptote right there, there's no points at -4. And the range is going to be -infinity to 1, and then 1 to infinity. Okay? Nice. All right, let's do this one. So x cubed plus 3x squared over x squared plus 2x minus 3. So we want to find the asymptotes first. Well, the degree on top is 1 greater than the degree on bottom, so we're going to have to use long division here. So we have x squared plus 2x minus 3 divided by x cubed plus 3x squared, and then I just put zeros in for the rest. So x cubed divided by x squared is x, so that goes up top. Multiply, we get x cubed, 2x squared minus 3x. Change those signs. So those cancel, and I'm left with x squared plus 3x. I'm going to drop the 0. Then we can divide first with first. So x squared divided by x squared is 1. So that's going to be plus 1. And then we can stop. Okay. So our slant asymptote is at y equals x plus 1. And then I would just graph this right away. So that means our y-intercept is at 1, and our slope is 1. So I go up 1 over 1, up 1 over 1, and there is our slant asymptote right there. Okay. Now let's find our vertical asymptote, and I'm going to do that by factoring everything. So I can factor out an x squared on top, and I'm left with x plus 3. And the bottom can factor to be x plus 3 and x minus 1. Now notice those x plus 3's cancel, and we're left with a whole. So then this is going to be a whole at negative 3. That should say x equals negative 3. Geez Louise with the typos. The whole at x equals negative 3. And then we're going to plug negative 3 back in to see what the y value equals. So then if we plug that back in, we have negative 3 squared over negative 3 minus 1, which is 9 over negative 4, which is negative 9 fourths. So we have a whole at negative 3, negative 9 fourths. Which we can graph that, so go to negative 3, and then negative 9 fourths. It's going to be about right there, because that's a little over 2. Negative 2. Okay. Now we can find our vertical asymptote. X minus 1 can't equal 0, so x equals 1, which there is our vertical asymptote. And now we are going to find our x-intercept. So x-intercept, that's where you set the numerator equal to 0. So x squared equals 0, which means x must equal 0. So we have an x-intercept there at 0. For the y-intercept, I'm just going to plug 0 in, which 0 over negative 1 is 0. Which makes sense, because if the x-intercept is at 0, 0, the y-intercept is also 0, 0. Then we can graph this. We want to look at our critical points. So our only critical points here are 0 and 1. So then if we plug in negative 1, we get a negative. If we plug in between 0 and 1, we'll plug in like 1/2, you get negative 1/2. So those are both negative. And then plug in 2, we get a positive. So our graph looks like that. Okay. And our domain here is going to be from negative infinity to negative 3 because of that hole. So because of this hole right here. And then from negative 3 to 1 because of the asymptote, and then 3 to infinity. And our range on this one is negative infinity to 0, and then 4 to infinity. And the way I did that is I found this minimum point right here. I'm going to show you guys in class how to find that and how to use a calculator to do that. Okay, let's do another one. Yes, booyah. So this one, we have x minus 6 over x squared minus 6x. So first we want to figure out the horizontal asymptote. So the degree on top is 1, the degree on bottom is 2. So that must mean that our horizontal asymptote is y equals 0. So it's just right there. Then we need to find our vertical asymptote, so we're going to factor it all. So we have x minus 6 over x times x minus 6, which it looks like we have a whole at x equals 6. To find the y-coordinate, we're going to plug that back into the simplified version. So that's going to be f of 6 is 1/6. So our whole is at 6, 1/6, which is right there. Okay. Then we can find our vertical asymptote by saying the bottom equal to 0, which would be just x equals 0. From that, since we have a asymptote on the x-axis and the y-axis, that means that we're not going to have an x and a y-intercept. And we can look at this like computationally. So the x-intercept, you set the top equal to 0. Well, 1 does not equal 0. 1 will never equal 0, so there's no x-intercept. We can do the same with the y-intercept, plug 0 in for the x's. But if we divide by 0, oh, shnikes, you just divided by 0. you can't do that. So there's no y-intercept. Okay? Then let's just do our line and see where this is positive, where it's negative. So if we plug in -1, you get a negative. If you plug in +1, you get a positive. So on the left, that's negative. On the right, it is positive. Okay? The domain here will be -infinity to 0, and then 0 to the whole, so to 6, and then 6 to infinity. The range is -infinity to 0, 0 to 1/6, and then 1/6 to infinity. Okay? I don't know why I put that. Probably because the dog was cute. All right, next. Okay, this one. So x squared plus 3x minus 28 over x squared plus 12x plus 35. So the degree on top is equal to the degree on bottom. So we're going to divide those leading coefficients. So we have the horizontal asymptote is 1 over 1, which is 1. And then we want to find see if there's holes and find our horizontal or our vertical asymptote. So I'm going to factor the top, factors to x plus 7, x minus 4. Factor the bottom, factors to x plus 7 and x plus 5. So those x plus 7s cancel, and we're left with a hole at x equals -7. And then I can plug that -7 in to figure out what the y coordinate is. So f of -7 is -7 minus 4 over -7 plus 5. So that's -11 over -2, which is 11/2. So our hole is at -7 and positive 11/2, which is the same as 5.5. So there's our hole right there. And then our vertical asymptote is going to be at x equals -5. Okay. Find our x-intercept by setting the top equal to 0. So x minus 4 equals 0, which means x equals 4. Find our y-intercept by plugging 0 in for the x's. So 0 minus 4 over 0 plus 5, which is -4/5. So right there. And then we can draw our number line with the critical points on it and see where this is positive, where it is negative. So if we plug in -6, you get a positive 10. So that's positive. Plug in 0, you get -4/5, which is negative. And if you plug in 5, you get 1/10, which is positive. So that graph is going to look like that. Cool? The domain here is -infinity to -7, -7 to -5, and -5 to infinity. Our range is -infinity to 1, 1 to 11/2, and 11/2 to infinity. Okay. I guess it's time to say goodbye. See you guys in class. Bye, guys.